Alright, you ready?
Yep.
Okay, first question. Can you simplify this over here? Could you simplify that?
No.
No, not yet. Because it's strange. Now what we're learning today, it's called integration by parts. Basically it allows us to perform integration on expressions that are the product of two functions. Now, looking at where this comes from, let's get some more real estate. That'll do. Suppose I had, welcome Matilda. Suppose we have the expression f of x, g of x. And what we want to do is we want to take the derivative of it. Any ideas? What would it look like if we took the derivative of this function here?
Look pretty similar to what it is right now.
Product rule. It's going to be f of x, g of x, plus little f of x, big G of x. Is that cool? Alright, next line we're going to get swifty. I'm going to multiply everything by dx. And I'm going to take the integral. So this is going to become f of x, g of x. This is going to be the integral of like so. Double integral on the right. And now I'm going to rearrange. Which one do we want to move to the left? This guy or this guy?
I'm going with some.
Which one, Madden?
Let's go with the one on the right.
Which one?
The
Oh, this one?
Yeah.
Okay. So we're going to go the integral of little f g of x dot d of x is equal to big F, big G, take away, and then it will be, oh, I didn't do what you told me.
Yeah, you did. No, not really. It's just...
Boom. What we call this is integration by parts. Pretty cool stuff, right? Did you know we could do that?
No.
You would have come up with it though, if you had to. So this is called the integration by parts formula. Basically, it's just the product rule, but then we rearrange it and integrate on both sides. So therefore, we have a rule that we can employ that allows us to integrate functions that are, or expressions that are product of two functions. Now, with this new knowledge in hand, could we potentially integrate something that looks like this? Yeah, we can. So our rule is going to be the integral of, let's say, I'm going to swap it up, f of x, g of x, dot dx equals big F, big G, take away the integral of, it will be little f, big G, dot dx. It doesn't matter which way you go, so long as these are the product of what would be the big functions, and this is opposite to that, yeah, it works. Seem cool? All right, let's go this guy over here. We need to have a think about how we're going to approach this. We have a rule. If we apply it wrong, we'll get something more complicated that we can't integrate. If we apply it correctly, we get the result. Now, the way you think about this is, what is easiest what can be reduced to 0 basically, or 1? Which of these functions could be reduced to 1? X. So what we're going to do is, x is what we're going to differentiate, and the other function, e to the negative x, is what we're going to integrate. So because we're going to differentiate x, I'm going to say f of x is equal to x. And the derivative of f of x is going to be 1. Conversely, I'm going to start off with g of x, because that is what we're going to integrate. E to the negative x integrated is going to be negative e to the negative x. Does that same sound? Okay, great. So we're going to integrate this guy. So let's apply our formula. Firstly, we're going to multiply the two big functions together. So this is going to be x multiplied by a negative e to the negative x.
Hang on a sec. Just a question. With your capital F of x
Yep.
and your capital G of x, that's a derivative of that one, and that's the original function.
Yep, so this is our, from here to here, we take the derivative of x.
Yeah.
Over here, this is the integral.
Yeah.
Sorry, this is our function, and
Yeah.
this is the integral of this guy. Do
And
you
you
agree?
just swap them. Capitals, or
No, so basically we ignored the second lines. If we multiplied that and that together, we get this, don't we?
yeah.
So if we go from big to little, that's a derivative, that's fine. But here's the point of contention, isn't it? To go from a littler function to the integral. So basically we select it in such a way that we've got big and little. It doesn't matter the order, you can rotate them around. Basically, the one we decide to be the derivative here is the one we can reduce to 1 by taking the derivative every time.
Yeah.
Does that answer your question?
Yeah.
Can you explain that a little bit more?
Okay. Would it be okay if we just finish the example and
Yeah.
then we take it back? All right. So this is what we have now. Subtract, and then we're going to get the integral here. Now looking at this, the next part is, if we've done the big function, what we're going to do is we're going to get the one that was easiest to differentiate and multiply it with this guy over here, the one that was easier to integrate. Putting this together, it's 1 times negative e to the negative x dot dx. Is that okay so far? Next, we simplify this out for a multiplication. Negative x e to the negative x. Take away. And then, can we integrate this? What would it be? It would be negative e negative x. So, yeah. Plus c. And then, simply grouping everything, we'll take negative e to the negative x out front. It's going to be x plus 1. Does that make sense?
Plus C.
Plus c.
Yeah, I think you can't go.
It's very cool actually, because it opens the doors to so many functions you can integrate now. It's crazy, the things that you can integrate with this.
Can you go through it from the top? Explain.
Yep.
Thank you.
Oh,
Let's
you
do
also,
it.
you also need one Like one of the functions to always be reduced to 0?
Not necessarily,
That's
no. In this case, it's what we're aiming for.
Yeah.
So I believe this is called, I've heard it once before, so don't quote me on it, but I've heard when I was at university, they called this reduction because you're reducing something such that it has an integral where one of the functions basically gets differentiated out at the expense of having a long calculation. But sometimes the objective is different, which we'll get to in a sec. So what we did was we got a function and we were clued into doing integration by parts because it is the product of two different functions. X is a function, e to the negative x is a function. Because of that, we know this is just our rule here. Now, because we're going to do integration by this, we ask ourselves the question, can one of these functions be reduced to a value of 1 or to a constant value? Rowan?
Yep.
That's the question I ask myself first. Can I reduce one of my functions to a constant value?
And what if you can't?
If you can't, then we'll go into that case after. But in this case, can it be done?
Yeah.
Yes. So what we do is we pick the function that we can reduce first. We say that big function, so f of x. We then find its littler function, which is the derivative. In this case, it's reduced straight away. The leftover function is opposite to whatever this guy was. So if this is big, this guy starts off little, and then we integrate to become the big function of it.
Okay.
Does that make sense?
Yeah.
After that, we simply apply the rule. It's always going to be the two big functions multiplied together. Does that make sense?
Yeah.
Secondly, it's always going to be subtract the opposite of what was here. This was big F, this was little g. So therefore this is little f, this is big G. Is that okay?
Yep.
And then we simply integrate as per usual. We may have to do integration by substitution. We may have to do integration by parts again. But we're always moving closer towards simplification. Seem cool?
Makes sense, yeah.
Okay. Example 1. Happy as Larry? Example 2.
You leave the right side up there.
Gotta take out the left.
Yeah.
So we get this formula on the formula sheet, right?
I can't remember. You shouldn't use it though. You should remember. Because the formula is useless if you don't know the application. This was A. This will be B. Let's go. We'll just keep it simple. I was going to get a bit fancy, but we'll do a fancy one after. Here's a bamboozler. What do we have?
Two functions multiplied.
Yeah, two functions multiplied together. This one's it. Sorry. Okay, two functions multiplied together. Now the question is, can one of these functions be reduced to a constant value if we kept applying integration by parts?
Yeah.
Yeah, which one would it be?
X squared.
X squared. So what are we going to make capital F?
X squared.
And therefore what would little f be?
2x.
2x. Hence, sine x becomes what? G of x. And therefore capital G of x is going to be,
Negative cos.
why?
Because that's like the integral.
Just cos.
But yeah.
There we go. Alright, so putting this together, the integral of x squared sine x dot dx is going to be the same as these guys multiplied together. Take away the integral of these guys multiplied together.
Methods. Differentiation.
Is that cool? Okay, we've solved that problem with another problem of lesser degree of difficulty. What do we need to do? We want to integrate this guy.
Do it by parts again.
Do it by parts again, so doubly by parts.
Wow.
Shouldn't the integral be just sine
Is there a mistake?
x? In your, like, after you've done f of x, g of x,
Yeah.
and you're doing integration by parts,
Mm.
should that just be in the integral? Should that be sine x? Or no?
It looks.
Look at the formula. Sorry.
That's okay.
More bit.
This is a complication of this one. It's confusing sometimes. Is that cool? 2 years ago, my class convinced me that I was wrong.
And wait.
No, not that time. All right, so what we need to do is we need to integrate this again. We ask the question, can one of these functions be reduced to a constant value? Yes. Which one? It's the f. So, f of x is f. I just reuse these because we're not writing them in the equation. This is just how I set things out. You can do the same or you can not do the same. It's up to you. G of x is cos x. Why? Just cos. So the integral will be sine x. Hence, we're going to get negative x squared cos x plus 2 in brackets. It's going to be the product of the two big functions, x sine x. Then it's going to be subtract the integral of the opposite of what we had up there. So it will be 1 sine x. Can we integrate this?
Yeah.
Any special method of integration?
Just a bit of cos, I guess.
Why?
Just cos.
Just cause. Okay. Remember the 2's out in brackets, so it will be 2x sine x. Then it's going to be plus 2 cos x plus c.
That's the answer.
That's the answer.
That is pretty sick.
That's integration by parts doubly. Twice over. Sometimes you have to do it 3 times over.
In a test.
Yeah.
Oh, okay, that's pretty sick.
Yeah, it's pretty good, right?
Yeah, I like that.
Because twice over is the same as 3 times over.
Yeah.
Hmm.
Alright.
Alright.
You get 100% on both integrations.
That'd be aura. That's probably me. It's, yeah.
Not aura.
Not more. Yeah. Have you done day yet?
Almost.
Final one.
Actually?
Yeah, halfway.
Oh, I'm so cooked. I'll smash that now.
Can I get rid of the one on the right?
Yeah. You're gonna have to. You're gonna have to though.
We've got it all in. Can you give it to the tech?
Well,
Clash Royale.
What, you got eBay Tesla now?
You say that?
What?
Everyone
This
is
guy's so stupid.
He doesn't know how to use
Easy,
it.
isn't it? That's fine. No, it's not that.
I don't even have any cards at level 12. They were like 13 and above.
Here's a slightly trickier one.
So every channel you can put that same level on. It's a lot.
What level you
Love me.
What level you
Oh, deep spirit.
This one's making me feel a little bit nervous.
Yeah, I paid the 60
Because I don't remember the integral off by heart. Like the other ones.
Let's try 50 out.
Rowan, what's different about this final one?
Oh, there's a.
You can't really reduce it.
There's, you can't reduce it to 1.
You can't reduce it to 1. Now, would there be any merit in trying to integrate this using substitution?
Oh, how do you substitute?
When would you integrate something by substitution?
When you can see it's derivative. One of
Yeah.
the functions is derivative.
One of them's the derivative of the other. This is not the case. So you either have to know some sort of rule to integrate. You would identify it as derivative. So two functions where one function is the derivative of the other, or you go for integration by parts. Now, because the first two conditions are not satisfied, the best bet is to go to integration by parts. Do we know how, or how would we pick which one to be which? Can't really, so it's like the best bet. So let's just say that this one will be f of x, sorry, big F of x. And this one will be little. Conversely, this is g of x. So therefore, the other one will be sine of x, like so. Putting this in the formula, actually we need LHS and RHS here. Putting this in the formula, we're going to get the product of these two, Ex sine x minus the integral of the product of these two, e to the x, sine of the x. And this is all still equal to the e to the x cos x. Is that okay? Did that help at all? Not quite. But there is a pattern to the madness here. Let's try again. If at first it doesn't work, try again. So let's try and integrate this by parts. What do you call repeating a method that didn't work the first time?
Insanity.
No, it's called persistence. What do you do? What do you call it if it doesn't work 2 times over?
Insanity.
Insanity. We're not insane yet. All right. It's going to be e to the x sine x minus, not that, sorry. In the bracket, we're going to go the product of these two, e to the x times negative cos x. minus the integral of e to the x times negative cos x. Cleaning this up, e to the x sine x. Opening this up, this will become a positive, e to the x cos x. And then we're going to get minus double negative, negative again, minus e to the x cos x dot dx.
How'd you get rid of the integral?
And then remember, what does it equal on the left hand side? Oh, sorry, I didn't get rid of that. What does it equal on the left? E to the x.
Cos x? With respect to x?
There we go. Have we made it simpler at all?
No. It's probably like 2 times worse. Chance how.
Look at the
Because now you got-
very far left hand side and very far right hand side of the equation.
Oh.
What do you notice about it?
They're the same.
They're the same.
Wow.
This is a recursive integral. So we're going to do something that's going to blow our minds. We're going to get this guy here and we're going to eliminate it from the right hand side by giving plus the integral of e to the x cos x to both the LHS and the RHS of the equation. Are we allowed to do that?
Yeah.
Yeah.
I don't see why not. So that's going to be 2 times, or 2 lots of, the integral of that. Then we have this. We're going to get e to the x, in brackets, sine x plus cos x.
Oh my gosh.
Now, have we solved the integral?
No.
No, because we wanted to find the integral of this. We know that twice the integral of this is equal to that. So what's the integral of this equal to?
Oh, 2. Oh my god.
How cool is that?
That's actually so.
That's the coolest integral we'll ever do this year.
So is that the test?
That would be convenient. I'd have no say over it, but imagine. So that's an integral that you evaluate, not by asking the question what can be reduced to a value of 1, but instead, let's give it a go and find out. Fiddle about and find out, I believe the saying is.
Is it? No, I don't think it is.
No, it is.
I don't think it is.
I think I would know these things.
No, okay.
Alright, are there any questions?
Is this about as hard as it gets?
Yeah, I'd say so.
And is the test next week?
Yep,
Next Friday, is it?
yep,
I
So-
don't like physics.
Thursday.
Physics.
yep, we'll be finished this topic by the end of the week.
When's methods?
Monday for the next
Oh,
week.
thank God.